Volume and Capacity Part 1. Hello friends, welcome to our student support program for grade 9. Today you will learn about the volume of a right prism. You will also learn how to solve problems involving volume of a right prism. Before we start with our grade 9 syllabus, let's recall what we did in grade 8. You have learned about the definition of volume. The volume of an object is the amount of space it occupies. And the units of measurement for volume are centimeter cube, meter cube, millimeter cube. Here are some real-life examples of volume. In grade 8, you have also learned about the volume of some 3D shapes, namely cube and cuboid. The formula to calculate volume of a cuboid is length multiplied by width multiplied by height. You will also recall that in a cube, all the edges are of the same length. So, if we apply the above formula and substituting width and height by L, we will obtain the volume of a cube, which is L multiplied by L multiplied by L, which is L cube. Now, in grade 9, you will learn about the volume of a right prism. Before learning about the definition of a right prism, let's have a look at some shapes illustrating different three-dimensional objects. First, we have right prism. A right prism is a 3D shape with two identical ends which are directly over each other. That is, they are perfectly aligned. They have flat rectangular faces and have the same cross-section all along its length. A cross-section is the shape made by cutting straight across the object. Then we have oblique prism. An oblique prism is a prism in which the ends are parallel, but one is not directly over the other. And all the lateral faces are parallelograms. Then we have non-right prism, for example, cone and sphere. A quick recap. A right prism has identical ends perfectly aligned and all the lateral faces are rectangles. Exercise 1. Which of the following are right prisms? For example, figure 1 here have identical ends which are perfectly aligned and the lateral faces are rectangle. Therefore, it is a right prism. This one is a circle, not a right prism. This one is a cone, not a right prism. Now that I have given you a few examples, you can complete this exercise on your own. Volume of a right prism. First, let's write down the definition of a prism. A prism has a uniform cross-section and it can be represented by a stack of many cards. Let's consider a stack of cards. The shaded region is the cross-section, and when the same cross-section goes along, we will get the length of the prism. So, to calculate the volume that a prism occupies, we shall take the area of cross-section multiplied by length. Therefore, volume of a prism is area of cross-section multiplied by length. Let's apply this formula to some examples. Example 1. Calculate the volume of the prism given below. Here you will notice that the cross-section is a triangle. We call this prism a triangular prism. So to calculate the volume of the triangular prism, first we write our formula, area of cross-section multiplied by length. Here the cross-section is a triangle, so we write area of triangle multiplied by length, which is half times base times height of the triangle times length. It is always good practice to show all your workings clearly. Now we substitute our values. Half multiplied by 4 multiplied by 3 multiplied by 7 will give us volume in centimeter cube. Simplifying this, we get 42 centimeter cube, which is the volume of the prism. Example 2. Calculate the volume of the prism given below. Here, you will notice that the cross-section is a trapezium. We call this prism a trapezoidal prism. Now we calculate its volume. First, we write down our formula, area of cross-section multiplied by length, area of trapezium multiplied by length, half times sum of parallel sides times height times length. Substituting the values, we get half multiplied by 10 plus 12 multiplied by 5 multiplied by 20 will give us volume in centimeter cube. Here, you will use Bodmer's convention that you have learned in grade 7, that is, bracket first and then multiplication. Simplifying this, we get 1,100 centimeter cube. A quick recap before doing the exercises. Volume of the prism is area of cross-section multiplied by its length. And also it is good practice to show all your workings clearly. Here are some exercises for you to practice. Exercise 2. Find the volume of the following right prisms. Exercise 3. Find the volume of the following prisms. Exercise 4. Find the value of the unknown. Part A. The volume is given, but the height of the triangle is unknown. We need to go and calculate the value of h. Part B. The volume is given, but the base of the triangle is unknown. We need to go and calculate the value of h. Exercise 5. The diagram shows a right prism with triangular cross-section ABC with angle ABC is equal to 90 degrees, angle ACB is equal to 60 degrees, and BC is equal to 10 centimeters. Given that sine 60 degrees is equal to 0.866, cos 60 degrees is equal to 0.5, tan 60 degrees is equal to 1.73. Part A, calculate the length of AB. Part B, given that the length of the prism is 24 centimeters, calculate its volume. Here, I will advise you to revise your chapter trigonometry before doing the exercise. Exercise 6. A water tank in the form of a prism is 20 meters wide, 0.5 meters deep in the shallow end, and 7.5 meters at the deep end. ABCD is in the form of a trapezium with AB parallel to CD. The length of BC is 25 meters, Part A, calculate the length of AD. Part B, calculate the volume of the tank. Now that you have done the exercises, you can also visit these links to help you with this lesson. So friends, today you have learned about the volume of a right prism. You have also learned how to solve problems involving volume of a right prism. I hope you have enjoyed this program. Thank you for watching. Till next time, it's goodbye.